Really backwards? All right. Good afternoon, everybody. This is the second Saturday DIY live stream, third stream overall. Trying to make a habit of this. I really enjoy building stuff. I don't have as many opportunities to do so as I'd like. So I'm using these streams as a chance to catch up on some of the stuff I wanted to do. So today I am going to build what is basically the next generation of the SDC-84 snare mic. And I'll show you what that looks like right here. Sorry. There we go. So I've already started this build, and I'll talk about what's different in a minute. But for those who have not seen any of the prior streams, I would welcome you to check those out. I'm archiving them on the MicParts website. So there's a page on the website that looks like this. This is the video tutorials page. And you can see the first one I did. This was when I built the T25, got almost all the way through. And then I came back, I guess last weekend, and finished it up. And then the other thing I wanted to mention is on this same page, there's a series of tutorial videos that are not live streamed. These were actually shot more in a studio sense, filmed here, edited, and then with the voiceover to describe the process. So those are the kinds of videos that don't make you sit through the process of building it so much. You know, the video fast forwards through a lot of that, but they do address specific techniques. So for today, that means that we won't take so much time. We won't take so much time to go through like soldering resistors and things like that, because the techniques have been explained before. They're in the prior streams, they're in these other videos, and that stuff's easy to find. So what I'm going to do today is just talk about this new kit and what's different. So first of all, thank you all for tuning in. Let me take a quick look at comments. See some of the same folks coming back, so thank you for coming back and checking it out. And I wanted to make another actually sort of announcement as well, and that is those of you who are building these kits, in general, if you have questions about what to do, how to do it, use these Saturday sessions to reach me if you have questions, and I can try to answer them as a sort of Q&A. I do want to make time in these for a Q&A. So with that, let's take a look at this guy. So this, well, this is the manual for the older, the current production SDC-84 Snare Mic. And this is a really popular kit because it's just pretty great on snare drum. I mean, that's what it was designed for. But there's something that's always bugged me about it, and that is that it's a little bit hard to build. Oh, one second. Clean HDMI. That. Ha. Okay. So, oh, and I should mention too, I've kind of simplified the setup today. There's quite a bit of setup necessary to do these streams, and it can't live here. This is actually part of the MicParts and Roswell production facility, and so I can't leave the video set up here like this all week. And so so today I simplified a little bit. I did away with the microscope. Again, for people who wanted to see the close-up of the soldering, we have videos about that already. And so I've got a different microphone as well, just trying to simplify everything. And I would appreciate feedback on how everything's working for you guys to make sure that this is helpful. Also, if you are enjoying these, please subscribe, please leave a comment so I can judge what to do next and if I should keep doing these. It's been fun for me, but if it's only fun for me, then it doesn't make a lot of sense to keep going. So with that, here's what I've done so far. I've already installed the resistors, and actually I wanted to talk about what's different about this particular version. I think I started this. So what had bugged me about the old one is that it was a little bit hard to assemble. Part of that was due to the metal work that we were using, but part of it was the electrolytics, which stand pretty tall off the surface of the circuit board. They barely fit inside the mic body. I mean, there's just not a ton of room in here. And so what we're doing this one, you can see the big difference is they're lined up right down the center. And I had to make some changes to the layout for that to work. So the new version is just easier to put together. That's the main change. Oh, the other change is that the original SDC-84 was designed for a specific transformer, and that transformer fit inside this cutout in the circuit board. And this is the transformer used for the normal SDC-84, and it dropped right in there. But the T14 that we use, which is a different turns ratio, it didn't fit. It literally didn't fit in the cutout in that circuit board. So we had to mill these out, all these corners, to make the larger transformer fit. It's still the same basic core size, but it ends up being just a little fatter, and it just didn't. The T14 just didn't fit inside there. So weirdly, it looks like this one's bigger, but they're not, because I know this one fits. So anyway, the other change here is that we made the cutout a little bit bigger. And if you end up building one of these, and this is true of the SDC-84 as well, the board is necessarily a little bit, I mean, these are the weak points, right? So you wouldn't want to flex this because this could snap. Now, in practice, I haven't heard from any customer that this has ever snapped, but I suppose it's possible. So when you're cleaning the board, you just need to be cautious of that you're not holding it by the ends and then sort of pressing in the middle. So resistors are down. Next up is the diode. Diodes are polarized. So, and this one is marked with the cathode. The cathode pad is marked. This might be the world's slowest focusing lens. There you go. So you see that D1 cath? Cath means cathode. See the black stripe there? You want the lead coming out of the black striped end to go into the pad marked cath. So we can get to soldering on this guy. All right, Mike, thanks for the feedback. Good to know it's working. I need solder. Oh, and I'm I'm going full nerd today. Got my, oh, sorry about that. Got my $12 goggles on here so I can see what the heck I'm doing. All right, so as always, clean the tip. And then I'm actually going to make some noise here so I don't gas myself out. Okay. Turns out the microphone is right where my elbow goes, so I bang into it sometimes. So my hope is to finish this today. We will see how that goes. Okay, checking on those joints. Something else I maybe didn't mention in prior streams is that in general with DIY stuff, when you're clipping these leads, depending on your cutters, these can launch themselves across the room. And so you need to be careful where they go and don't shoot yourself in the face or somebody else nearby. So you can either aim them down into your discard bin, or you'll see me put a finger up, which just catches the lead as it comes free. Okay, so diode and capacitors. So this is it. This is not a complicated circuit. One thing to be cautious of, though, on these is, like I said before, there isn't a ton of room inside the body, and so you kind of need to be careful of height. So what you'll see me do a couple of times here is solder one lead, which I'll do right now, and then check to make sure that the cap or the component, whatever it is seated all the way down against the surface of the circuit board. Okay, so I think I got that one. So yeah, it's a little bit tipped, but it's not standing way up, meaning too far away from the board. But the way you would reseat that is you would reheat. So first you just solder the one leg or lead, then you press down on it and reheat that one joint while pressing down, and that's it. And then we can come back and do the other. Like that. Okay, one down. All right. What's next? Okay, so 2 of these at C6 and C10. So what's next are 2 film capacitors, and these are not polarized, meaning they can go in either orientation. Okay, they can go in this way or 180 degrees. What I like to do is these tend to be stamped only on one side, depending on the brand of capacitor and what line it is. So these are WEMAs. Sometimes some of the WEMAs are stamped on the top, but in a lot of cases, the value marking is on one face, and then the back side might have nothing, or it might have the tolerance. I think this one's a, what does that say? 10. So this is a 10% tolerance part. But the important thing is this, and so because this is DIY and we might have to debug this later, I think it's a good practice to put these in so that you can read the value after you install it, meaning facing out. Only because there's something right behind it that might obscure it, meaning if you tried to read the value from this side and there's something installed right behind it, you may not be able to read the value. So let's throw these 2 in, C6, C10. And then when I do these, I usually just lay the board down and have gravity sort of hold the board against the parts. That works in most cases. With these small boards, it can be a little tricky. I was playing earlier with one of these. These are pretty cool. This is a circuit board clamp or vise, I guess. And what's nice about these is that you can rotate the board without taking it out. So you can solder one side, solder your leads, and then spin the thing over and check. And I do use that sometimes. But the components will fall out, so you have to tape them down when you do that. So let's see if we can get this going here. Sorry, this is bad practice. Should really clean the workspace up a little bit. There we go. Okay, so that's those 2 film caps are part of various RC networks. This is the output cap. So that's going to go there. I want to do these first. Yeah, that's fine. Okay, so this is one of the tall caps. So you definitely want to make sure that it is flush against the circuit board so it doesn't interfere later. Okay, next up are the electrolytics. So these are polarized, which means long lead in the positive pad. And in this mic, in all the kits that I make, I try to align all the electrolytics so they all point the same direction. Sometimes it's really not convenient to do that, and you end up having to run traces awkwardly to make that happen. But in this case, I was able to do it. So what that means is the black stripe, which indicates the negative side, is going to be facing the same direction for all three of these, and that is facing down towards the transformer. So those three go in like this. Come on. Okay. It is a little, yeah. It would be better to have this be more solidly braced. So you know what? We have the technology. Let's just do this the right way. All right, so this is very high tech. All right, so that just serves to sort of hold everything in place. And then we can put this in here. So this thing, this clamp on this side is spring loaded. There you go. So like I said, you can spin it. But we're still going to just tack one leg of each. So it's good to sort of prime the tip of the soldering iron. The fresh solder helps the heat flow. And it cleans the tip, of course, too. Sorry, I'm having some technical issues here. There we go. So like before, we're just going to do one of each. Whoa. Oh, I see. I hadn't, hadn't trimmed these other leads, and they get in the way. Yeah. So here, this is an example of what we need to be careful of. See that gap on this guy? You can see the leads between the body of the capacitor and the circuit board. That's bad, but easily fixed. Because that's, just like I said before, when we get to this point, that's the kind of thing. you have to watch out for. I mean, the leads are in the way too, but you can see there's just not a lot of clearance there. So what are we doing? We are going to reseat this one for sure. And try not to burn myself in the process. There, hear that click? Good. I'll grab this guy. I think that's good. This one looks like it's already down. Yeah. All right, so now we're back to the rest of the soldering. When you do that and you need to sort of reseat something, heat up the one lead and press down, it can be good to come back and reflow that joint. This one. There we go. So this one here is a little hard to get to because just the way it's bent over a little bit, it kind of gets in the way of the tip of the soldering iron. So I'll just move that out of the way. Good. Now that's the one I reflowed. Actually, it looks good though. Yeah. Oh, sorry. It's not going to give it to me. There it is. So a little heavy on the solder there. It's not a problem, but it's more than needed. So we can trim these off. So what's left on this is really not much. I mean, the final assembly is a little bit involved because wires are always harder to do than components. But you can see there's just not a lot left to do. So we need to build the input circuit. And because this is a high SPL mic, we need to pad the input. So there will be a pad cap up in front. We need to drop in these terminals, which I left off my list. So I prepped the JFET already. I think that's next. I scrubbed the pins. These new old stock JFETs can get a little tarnished. So I scrubbed them already. And I think I'm going to put the terminals in first. If I can find them. Here we go. So these are insulated terminals. So this is a Teflon sleeve. This pin is conductive, of course, and it goes straight through. And the point of these is to keep high impedance joints off the surface of the circuit board, because audio signals running at very high impedance, as set by the 1 gig resistor, will happily leak into the surface of the circuit board. Another way to say that is air is a much better insulator than circuit board material. So in some of the LDC kits, including the T25, which is not an LDC, but in a lot of cases, in a lot of the kits that we make, we'll use a switch with a bent pin. You might remember this from the earlier stream. We use a switch whose pins are bent out. You can refer back to one of those other streams to hold this high impedance joint off the surface of the circuit board. Here, what we're using instead is these terminals. And these can be a little snug fit. They're supposed to be a snug fit. So there are various ways to put them in. You can grab the top of the pin and try to just wiggle it in to this the hole a little bit. So that one kind of went in pretty well already. And the other option is, it's going to be hard to show. You could do this on like the edge of a table if you have something more sturdy than this, but this is just for demonstration purposes. You can press this down on a surface, obviously not with the components in the way, but press this down on a surface in order to apply even pressure. And again, wiggle it a little bit and try to walk those pins in. And again, with this board, you wouldn't want to press back here and snap the thing in two, but something like that. It's not critical that I zoomed in. It's not critical that the shoulder of that white Teflon piece is flush against the board. Yeah, I need to work on my focus on there. Wow, it's taken forever. But something like that is fine. Once the terminals are in, the next step is to drop in the JFET. So in this JFET, pins 1 and 2 are the source and drain, and they are interchangeable, meaning the JFET would work no matter how, no matter which of those pins is acting as source or drain. But the gate is not, the gate is pin 3. It has to be pin 3. So it goes in this way. You line it up with the semicircle outline on the surface of the circuit board. And by putting that 90-degree bend in there, we can intersect with this terminal pin right here. So for now, what we're going to do is just wrap that around, sort of like this. You don't want to pull too hard, but something like that. All right. And then we can clip off the excess like that. So just make sure we got a nice connection there. Also make sure that the JFET isn't standing up too tall. Now, these are pretty tall, and it's unlikely that your JFET would ever be standing taller than that, but that is absolutely the ceiling right here. So it needs to be sitting lower than that. And now that that's on there, we can solder the two leads that are below. The other nice thing about this device is that it raises the work surface. So if you're having trouble seeing, it can be handy to have this up off of the table a little bit. Makes it a little bit easier to see. So we're coming in right in here. Whoa, I see. All right, Jason, thanks for the question. Jason asked, how do you clean the leads of the JFET? And what I use is a cotton swab and alcohol, which is how I clean almost everything. This is 99%. 91% would work just as well. I do like isopropyl because it leaves less residue than some other formulations. There are also commercial flux cleaners that would work just fine. The one we used to use is sold as an aerosol, and it just kind of makes a mess. This is the big bottle is nice because you can dunk a Q-tip in it or a cotton swab in it and then put it wherever you want. And so before the stream, I did just wipe off the leads of that to get it clean. So you can see what this ends up looking like there. soldered down. So next up are the 1 gig resistors. So this mic has 2, which I maybe didn't get out. All right. Okay. So this circuit was designed to keep the entire high impedance input section of the mic off the surface of the circuit board. So what's going to happen is signal comes in one side, goes through an input cap, which will be below the board, and then goes into the input of the JFET, which is the gate, that third pin there. And so both sides of this need to be held off at high impedance. So before we do that, and there's a picture of this in the book, but basically you take this, bend one leg over, grab it about there, and do that to it. And then same with this one. And you need to be a little careful with this one to not leave too much of a bend at the top. Let me demonstrate what not to do. What you wouldn't want to do in this mic is something like this. Never actually done this. Oh, that's actually not terrible. Let me let me try to do a bad job a second time. Okay, this is super exaggerated, but that's the idea. You wouldn't want to do this. There we go. Because this, if you have this big piece poking up, that will run into the inside of the mic body. So these vertical resistors need to be set up so that they're bent close to the body of the resistor. Jason, to further answer your question, you could clean component leads with like steel wool or a Scotch-Brite pad, which I think is what you mentioned. I know people do that with like pins on old tubes, which can also suffer from aging, I suppose is one way to say it. You just need to be careful of residue. You wouldn't want to leave residue on the component, and you wouldn't want to do it. You wouldn't want to sand things on top of your assembly such that dust and sand and stuff is kind of getting into everything. Now, the risk of soldering these parts is that when you turn this over, they fall out or move, and it's a little fiddly to get these where you want them. It's not difficult, but getting them right where you want them is tedious enough that you don't want to have to do it 3 times. So what I'm going to do is solder one at a time, and I'm going to tape this one down in hopes of having it not move while I'm soldering. Here we go. See, they fall out easily. One would think that by wrapping the pin around that socket, because the socket has a little head on it. Sorry, the pin of the terminal is what I meant to say, has a little head on it. But in practice, it's actually difficult to have the lead of the resistor grip that terminal pin. So we'll just do this in hopes of keeping that thing on there and not taping our way into the joint. Is that going to come off? There we go. That still looks good. Okay. So you'll see too, I move these things around a lot, trying to find a good way to provide access, meaning I need for the soldering iron to be able to get in there. I'm just going to double check my positioning here. I think that's good. Because it happens actually fairly often. It can happen if you're not careful, that you get this all set up and then you soldered and you realize it slipped. So take your time to position these things so that you can get in at a good angle. That went well. Oops. Yeah, that's what we want to see. We want to see it not having moved. So now that that's in position, we can, this resistor only needs to go as far as that terminal pin right there. So we don't need any of this. So that's done. And that's done. Okay, same drill here. So this terminal already has the JFET gate on there. And it doesn't matter really if you come in from the outside like that or from the inside. Okay, so that's in place. Now I can try to clamp it in a little bit like that so it doesn't move. Especially with these high impedance joints, it's really helpful to prime the tip or tin the tip to help with heat transfer. Come on. There we go. Let's see if it, yeah, good. Okay, that's what we want. You can see also that we want these vertical resistor leads, the ones up on top here, to not be flying outboard where they can run into the mic body. So it's not so much an issue for this guy, but for this one over here, you wouldn't want it installed so that it's leaning out that way. You want it to be vertical. You can see that here. You wouldn't want it tipped to the right as you're looking at it. Okay. So now we have some excess lead here that can go. All right. And then this is finished as well. I mentioned in a previous stream, you can clip these right at the top of that solder cone. You don't need to leave a sharp piece of wire poking out. In fact, you don't want a sharp piece of wire poking out. Now we can actually solder this input joint here. We don't want to do this one yet because the capsule lead will come into this, and we only want to solder that one time just to reduce the number of heat cycles on any given component. So, but this one's done, so we can do this one right now. I think what I'll do is this can go either way. Another question from Jason, is the high impedance needed for frequency response? And the answer is no. The high impedance is needed just for good signal transfer. And for low noise as well. Okay, so what we need to do is solder this guy right here. So these JFETs are not particularly sensitive to heat. Nevertheless, minimizing time. I often say it's minimizing heat, but the truth is it's minimizing time. By the way, if my audio is clipping or distorted, let me know, because I kind of moved the mic closer, and I can't see the level meter without turning my head, which makes my voice quieter in the mic. So if the audio sounds non-optimal, please put something in the chat. Anyway, we want to minimize the heat, and that means cleaning the tip and then just being really kind of quick on this joint. And you also want to make sure, I think I got a good one there, you want to make sure that the solder encompasses the entire assembly right there. I mean, you have two components. Yeah, that looks good. You have two component leads, and you have the head of that terminal pin. And the pin is actually in circuit in this mic, meaning signal's actually coming in the bottom of this pin through a cap that isn't installed yet. So the solder connection needs to encompass the top of this pin, as well as pin 3 of the JFET, as well as the flying lead of the 1 gig resistor. So that solder blob needs to flow around the entire area there. It should not contact the surface of the circuit board. It wouldn't want to, because there's nothing conductive to pull it down there. But if you're feeding in, 6 inches of solder and it overflows, that would be bad. So what's next? 1 gig resistors, pad cap. So in the SDC-84, which is not the Snare Mic, but rather the sort of general purpose version of this circuit, which has a number of different, the SDC-84 has a number of different changes, different transformer, some different values here and there. In that mic, the SDC-84, the pad cap is optional, and it kind of depends on what you want to use the mic for. If you are building an SDC-84 for acoustic guitar, you probably wouldn't want to put a pad in it. If you wanted to buy yourself some extra headroom, then installing a pad cap is a good idea. When I say pad cap, what I mean is a capacitor that's acting as an attenuation pad. And that's what this is. This is a silver mica capacitor. And it is about, for this Snare Mic kit, what we include is something between 30 and 40 picofarads, depending on what we can source. This one happens to be 33. Now, because this is part of the high impedance circuit, one lead has to be off the board. Yeah, and everything I said 5 minutes ago was incorrect because that joint wasn't done. This thing has to be in there too. So that's what you get for building with an audience. You get to own your mistakes. So this actually will be a little trickier now, because now that this is all soldered on this terminal already, it's going to be just a little bit harder to add the pad cap, but I think I can get it in there. So now height is still an issue. We wouldn't want this capacitor to stand up any taller than the electrolytics. So we will tape this in place. So I use this blue tape because it doesn't have a lot of adhesive on it. This is like special painter's masking tape designed to not leave residue or pull up your paint or wallpaper or whatever. The downside is it's just not very sticky. So sometimes it doesn't stick very well to whatever it is you're wanting it to stick to. So you just have to be cautious of that. Now, what am I doing? So I'm not paying attention. So I just put the tape right where I need to solder. So I think I'll come at it like this. All we need to do is hold it in place so that that lead is on the terminal pin, which it's kind of not. Let's see if we can reposition that. The other thing to watch out for So we're doing okay here, but what you need to be careful of, see that gap right there? I don't know if I can get something to point in there. Let's see if you guys can see this. So you can see there's an air gap right in here. That's important. You don't want that bent lead to touch the surface of the circuit board, because again, that's part of the high impedance circuit. This capacitor, if you saw the earlier stream about the T25, and I talked about the pad capacitor there, this one is acting in much the same way. It's taking a small amount of signal off the JFET's output, the JFET drain, which is inverted with respect to the input signal, and feeding it back into the gate. So it's a feedback mechanism, and it's taking basically reversed polarity audio off the output and feeding it back into the input in order to reduce the output level, actually to reduce the input level. And as such, it's part of the input circuit because it's literally connected to the JFET input, which is connected to the capsule. So if that little elbow, if that bent lead of the pad capacitor was touching, then all this business with the terminals and flying leads and stuff is sort of for naught, because you've shut the whole thing against the circuit board after all. So let's not do that. I also realize the more I talk, the less likely I am to finish this microphone today, which was actually the goal. How are we doing on time? Not very well. All right, let's throw this in here. So I see a question from Seth Novak. Do I have plans to make external pads between the capsule and the mic body for flexibility? I think what you're talking about, and correct me if I'm wrong, is detachable pad like attachments. Like, do I remember right that the Octava MK012 does that, right? There's like a screw-on external pad that sits between the capsule, the detachable capsule, and the head amp. No, I don't plan to make those because it would be very expensive to do, and I think of limited use. At the moment, no. Okay, so that's that. Now we can drop this guy off here after we've soldered it, perhaps. But if that wasn't your question, let me know. All right, where am I? Right here. Okay, so just reading my notes. So that is it for the main circuit board stuffing. Now the next step is to clean the board, which I'll do quickly. So I showed this technique on that first stream, and there's actually a technique sort of demonstration video of this on the website as well, where you take a paper towel with some solvent on it and you just sort of scrub, and be careful that you don't snap that circuit board. It's also helpful to go both directions. And now I'll make another plea for not bending component leads when you put them through the board. I know a lot of best practice videos and instructions will say, insert the component into the board, put the leads through the board, and then bend them over to hold them in place. And if that's your style, more power to you. But what I've found is that that just makes solder joints bigger and messier and harder to clean. So I tend not to do that. I tend to To leave them straight, tape the components down so they don't fall out. And I can see that I left a few of these a little bit long, but you know what? They cleaned up okay, so that's all right. So then you can use an old toothbrush or something to brush away the residue. All right, what do we have? Clean board install transformer. Okay, so I pre-cut the leads on this. I didn't strip them. So that's where one of these comes in very handy. You just need to be careful that you don't cut the wires, obviously. And if you don't have one of these, if you need one of these, there's a link to this specific tool on the website, the MicParts website. There's a DIY tools page that identifies this model. They make these for different gauges of wire, and you need, I think it's the finest one they make. I think this is the finest gauge. I could be wrong, but this apparently goes down to like 32 AWG. And if you don't have one of these, you can certainly strip wire with a razor blade. I did that for years. It's kind of a pain, but you can do it. Now there's a specific way that this transformer should be installed. So black on top and towards the front of the board. Oh yes. When you're working with these, you need to be careful that you don't pull on the wires. It is possible to pull the wires out of the transformer, and you'll know when you've done that because the mic won't work. And this just takes a little bit of fiddling to get these wires where they need to go, because you need to split them top and bottom of the board. You can see it's just a tight fit. So we bring the wire through first. There we go. Look at that. Drops right in. Pretty cool. Right. Okay, so the in this revision, the pads are marked. TP1 stands for transformer primary 1. Now this can be a little tricky. Some people will wonder, should you tin this wire? And you certainly could. I'm not, because I don't want to take the time. And when you do tin them, you need to be careful that you don't put so much solder on that you can't fit it through the circuit board anymore, because then you have to strip it back off. So here's the tricky thing. That's where this needs to be soldered. And what you don't want to do is come in with the soldering iron and bump it into one of these caps, because best case, it'll smell bad. And worst case, especially for the film cap, you could damage it. So if you want, and you have a steady hand, you can certainly solder it that way. There is room to come in sort of over the resistor and get to it. The other option, and what I think I'm going to do, is leave just enough lead showing here that I can solder it on the backside. So let's try that. All right. Not sure I got that. No, didn't think so. Oh, yeah. Yeah. There we go. Yeah, so that's that one. That was transformer primary 1. That's the input, the audio input of the transformer. TP2, which is the other side of the transformer primary or input, goes back here to that TP2 joint. And so the wire wraps around like this. The manual gives specific lengths for how to trim these, which I did in advance. As I mentioned before in an earlier stream, whoops, I tend to try to solder wires one at a time, because if you take the trouble and time to place them all, chances are one or more will pop free before you get a chance to actually solder it. So we can hold this in place. This one's easier to do. Okay, so then the secondaries are next. That's the transformer outputs. So there's a color correspondence. The main signal input is red, so TS1, which is the corresponding output wire, is pink. So red to pink, black to gray. So TS1, that's TP1, this is TS1. Whenever you're installing wires, you need to be careful that, especially if they're not tinned, that they don't splay out when you insert them and then short out against a neighboring pad. So you can see that there is no, at least not as far as I can see, any loose wire ends that are going to cause problems later. And I think we're going to do this guy. So what's left to do here is a couple of wires, and then, so it's not super sturdy, but maybe this will fly. So we've got 1, 2, 3, 4, 5 wires, and then the input joint, which like these is a little tricky to get to, but ultimately not that difficult. And then the input cap, and then we're done. So this leaves one transformer wire, TS2. So whenever you build a microphone with a transformer, you can do a polarity check after. The way you do that is a couple ways to do that. if you've never heard an out-of-phase mic before, this is what I would recommend. Get a figure of 8 mic and then listen to the backside, meaning like a figure of 8 condenser mic, and then put on headphones and live monitor the output while you're speaking into the backside of a figure of 8 mic. And it'll sound hollow, especially as you vary the distance between the microphone and your mouth. You won't hear what you'd normally expect from a cardioid mic in terms of, as you get closer, you'll get proximity effect, yes. And it'll be louder as you get closer. So those effects will be different on the backside of a figure 8, because the backside of a figure 8 has reversed polarity as with respect to your own voice. So what you'll experience is basically comb filtering that's happening inside your skull, which is kind of bizarre and sounds weird, sounds like nothing else you've probably ever heard, unless you've heard that before. So if the mic is out of phase, it might have some of that effect where it sounds hollow in a weird way. The other way to do it is to put the mic that you've built up against or next to a microphone of a similar type that you purchased, a commercial mic, and then mount them side by side, and then snap your fingers or clap your hands and record that, and then look at the waveform. And if one goes up while the other one goes down, then the one you built is probably out of phase, unless the one that you bought was out of phase. And I shouldn't say out of phase, I should say reversed polarity, which is more accurate. So that's the transformer. Next up is the input capacitor. So this is another silver mica cap, and these are pretty handy because they fit almost perfectly over the terminal wires here, terminal pins. And the other thing I like about these is that they lay pretty flat against the circuit board, and there's just not a lot of room in this mic. So we can throw these on next. So as is generally true of soldering, you want to heat both of the things you're trying to solder. So in this case, you'd lay the iron into that joint so it's touching the terminal pin as well as the capacitor lead. Then we can clip off the excess. And we can also clip off these terminal pins now that we've soldered the input cap. And for this, because these are pretty heavy, I tend not to use my best cutters. I prefer to use something old that's got some divots in it already. And definitely block these from shooting, because if it bounces off a wall and hits you in the face, you will regret it. The thicker the component lead, the farther it's going to fly when you snip it. Okay. So we can do some of the cleaning later. And for the next stream, I can fix the autofocus area on the camera so it's a little more generous. Next up is mounting this. So we've got pre-wired XLR insert. This is pin 1, black. Okay, so we just pull this off. The way this goes in is, you can see there's a mounting slot here towards one end of the, meaning towards that end of the housing. So it will come together like this. The components will be on the side of the board where there's more room for them to be. So before we do that, though, we're going to install the wires. So here's XLR1, which we said was black, and we always double check these. XLR1 is black. And just to confirm, the bottom side of the board has the legend on there too. Okay. XLR2 is red. So, am I doing this the way I want to do it? Yeah, wires go in the top, get soldered on the bottom. XLR2 is here. See, that's the risk of not tinning these. All right. When I lay out these boards, there's always a balance to be struck between making these solder pads large enough that the wire can go through, even when it's tinned, but not so large that the insulation also wants to go through. And that was the thing that burned me the other day in that other stream where one of the wire insulation ends went through. Okay, then we just double check. So that can make it a little tricky. Okay. XLR3, it's the one that's left over. Just like that. I would normally take the time to brace this better. I suspect not many of you will be building these in a live stream, so you're free to use better technique than this. Because I think these, in fact, I would love to get feedback from people if these streams are more useful as demonstrations of technique or as demonstrations of how easy or difficult it is to build these things. I mean, is the point that you can build a mic in an hour, or is it the point to really drill into techniques because you've never done it before and you need that kind of input? That sort of feedback would be useful to me. Okay, next up. I'm taking a, it's going to be hard to see, but I'm just getting a Q-tip or a cotton swab. So Paul Bogan asks about my favorite DIY mic pre's. I don't have any. I know not personally, but I know the guys from Hairball. I know Peterson from DIY-RE personally. I am very much inclined to trust both those guys' stuff. I think they both do a really nice job based on what I've seen. I also know JLM from Australia. I believe he's got mic pre's. But I haven't built any. I will be building a pair of JLM opto compressors, and I might do that on this stream. Don't have a schedule for that yet. So I can't answer your question in the sense of, I built it and I love it. Cappy, of course, has DIY mic pre's too, and I would be inclined to trust those as well. In fact, I own a pair of Cappy VP312 Platinum pre's. Those are not DIY kits. I had them build them for me, mostly because I bought a pair of the JLM opto compressors. I bought a pair of those kits as a quote unquote quarantine project in March, and they're still sitting unbuilt. And so I realized I don't have nearly as much time to build stuff as I'd like, which is one of the reasons I'm doing these streams. But yeah, so if you guys have favorite DIY mic pre's, let me know. I would be curious to hear what your experiences are. Okay. There we go. So the next step is just inserting this in. And I think I might be having, I think this screw is in a little bit tight. Where's my, just backing out that screw a little bit. Not quite sure what's going on with that, because I test fit this before and it went in fine. There we go. So when this is in, you want to center it side to side, and so that it fits handily inside the mic body. And then tighten these screws down. Do not need to go crazy with the torque on these. Just got to tighten them down so it holds. You do want to see that this is flush on both sides. Okay, so we are practically done. We're probably 5 minutes from fire up here. Did I flip pins 2 and 3? I'm not sure what you mean. Did I reverse them? I hope not. I'm not sure what you mean. The BGE, your question, did I flip pins 2 and 3? I don't know what that is, so let me know. One thing else I should mention too is if you watched the earlier stream on the T25, when I was testing voltages on the T25, I probed continuity across XLR 2 and 3, and was it across 2 and 3, or was it from XLR pin 3 to the XLR 2 pad, and it beeped, and I said, oh, I can explain that. And then when I was watching it again, I realized I hadn't explained it. So what's going on there is the transformer secondaries on that mic. The secondary measures right around 50 ohms. And my meter treats anything up to 50 ohms as continuity. So the meter beeped on that one. So that's what was going on with that. Now let's grab this input joint. So the kit comes with a nose cone. This has a spring pin to connect to the capsule. This is the input wire right here. And so we want to install this like this. And that input wire needs to connect to this terminal right here, which we haven't soldered yet. So the way that I do this, and this is this is explained in the manual, you don't want there to be a ton of tension on that input wire. So you wouldn't want to, for example, solder it like this. That gives you plenty of space. But then when you close up the mic, you're asking that wire to make like a 180-degree bend in it as you push this on. And that's bad because you wouldn't want to break that wire. So what I recommend doing is tightening the opposite screw. I'm just checking here. I'll talk about that in a second. So I tighten this screw a little bit just to give it a little bit of a grip on the board. So I can back this off just a little bit. So you can see the nose cone is just a little bit skewed. That's what I want right now, meaning it's pointed off that way, just to give myself a little bit of room here. And then I'm going to solder that input joint. So for this, I definitely want to clean and tin the tip of the iron. Just checking to see that the wire is on the terminal pin, not below the pin on the insulation. So you can see there, after about a second of holding the heat on, the solder was at first sticking to the tip of the iron and then started to flow, and you can see it flow. And yeah, so it's you can see that it flowed onto the once my focus wakes up, you can see it flow onto the that brass or whatever this wire is here, the input wire. Although I am going to reflow it because it doesn't look like it quite flowed as well as it should. All right, that's not going to cooperate. That's better. So then we can clip off, where's my, the excess input wire. And you need to be careful that you don't clip the wrong thing or reach the tip in too far and, scratch one of the components. Once that's done, we can tighten down this nose cone. And as we did with the back end, the nose cone should be centered on the circuit board side to side. I don't know why this focus is being so stubborn. It's a little frustrating. So you need a very fine tip screwdriver to reach in there. Again, you don't need to torque this down, just enough to grip the circuit board. And the last thing we check is that the input joints or these terminals aren't touching the plastic nose cone, and they are close, but I can see an air gap. It would be okay to install this nose cone with a little bit of a gap here, meaning offset the nose cone a little bit that way in order to make clearance for this. All right. So the next step should be cleaning those input joints up, the stuff we just soldered. But just so we can get to the end of this, I'm going to do the final assembly. I see. So your question was, it looked like XLR2 went to pad 3. If it did, that would have been a terrible mistake. I thought I checked that. I can check it right now. So XLR2 is here, which is red. And the red wire is it is difficult to see. No, yeah, red wire went to XLR2, and that is what's right there. So no, I guess the bottom line on XLR wiring is follow the manual. Wire color is irrelevant. What's relevant is what's connected to what. Okay, so XLR pin 2 needs to be connected to the pad marked XLR2. Okay, so here is the last assembly step, and that is you line up. So I've pre-installed the set screws into the XLR housing, and then you line them up so you can see the screw head through here. And then you just back out the screws. And you can go a little bit at a time to help them seat themselves. So the circuit board here that I'm using is a prototype. That's why I called this build a prototype build. So let's let's see if it works. I didn't bring another XLR cable that's going to be in frame, so I got to step away for that. So the Snare Mic comes with a hypercardioid capsule, the SDC-84, meaning not the Snare Mic edition, but the basic, the basic SDC-84 mic comes with your choice of cardioid, hypercardioid, or omni capsules. So that's the end. I will be back in 10 seconds to plug this in and see if we get sound. All right. So okay. What am I doing? How about that? How about that? Yeah. So you are hearing me through my voice mic, but I can switch that. Now this. Testing audio. So the challenge, you can hear that. The challenge with this mic is that this is the Snare mic, so it is padded and it has a high turns ratio transformer. So there isn't a ton of output level from this. So I've got this gained up pretty hot, but you can hear that it works. And it's also not a great vocal mic. I should point that out. Small diaphragm mics in general, they have no plosive protection because the capsule, the diaphragm, is right up at the nose of the thing. And if you compare that to a large diaphragm mic, the diaphragm is set back and there's 2 layers of mesh screen, and that's designed for plosive protection, and these don't have that. So this is not a vocal mic, which is why I'm holding it like this, because if I were to hold it in front of me, it would pop like crazy. Not a fault of the mic, I think every small diaphragm mic I've ever owned does that. But we do have signal, and that was the key. So the next steps on this one would be to clean those couple of input joints. Sorry, I'm just going to turn that back. Clean those couple of input joints, and I think that's it. So that's that. So the Snare Mic is available. It is for sale already. The version that we're selling is slightly different than this, slightly different circuit board layout, and when you do the assembly, because those electrolytics are offset side to side, when you assemble it, it's just a little bit of a tighter fit. But this one will be out in 30 days. I need to order circuit boards, and that's as soon as those circuit boards are here, that's when that's going to come out. So I think that's it for the build. Let's take a look at that. Any final questions? No, right on. Well, everyone, I appreciate the I appreciate you coming to join again today. If you haven't already, please subscribe, leave a comment on the video, and let me know what you want to see, because that's really helpful to me to figure out the best way to do this. So right on. Thank you. See you next time.